So for the next slide, or video for 9.1, I want to combine the things that we've done up to here. We've done translation, horizontal, vertical, and we've done reflection in the x-axis, reflection in the y-axis. I only used one of the reflections here. I used reflection in the x-axis, flipping things upside down. Okay, so this function here you have to recognize as the basic function as being y equals 1 over x. It's called a reciprocal function. It's a rational function, it's a type. We did these in chapter 5. And this is especially simple rational function, probably the simplest. Okay, so that's our basic function. It's a hyperbola is what it's called, the graph, and it has these two asymptotes that are the x and y axis. Okay, so, and the point 0, 0 here is called the center. It's not a point on the graph, so it's not called a vertex. The vertices are actually this point here and this point here, just in case you were wondering. Anyway, so this is called the center right here, where it's 0, 0, where the two asymptotes cross, the horizontal and the vertical asymptotes. Okay, so now we need to see what we do to get from this function to this function, right? And so the order, it's important to do these in the correct order when you're doing several transformations. And the smart way to do this is start from, imagine you're evaluating this function at some number. Say you put 2 in for x, right? What's the first thing you would do? Well, you would add the 2 to 3. So do that transformation first, okay? So how does that transformation go? Well, that's the denominator of this function is actually the, quote, inside of this function, which is where the x is, right? So I want to take that inside stuff and set it equal to 0, just like I did with absolute value functions, right? So x plus 3 equals 0, you get x equals minus 3, so it's a shift left 3. Okay, so I draw it, and I just shift the whole thing, including the asymptotes, left by 3. Asymptote shifted means the center shifted left by 3. Notice the horizontal asymptote it just shifts along itself, so it doesn't actually change. It's still the x-axis. Okay, and then if the vertices shifted, right? And it just looks kind of like that. And I wrote that's the function y equals 1 over x plus 3. Now, if you were plugging a number into the original here, say 2, you'd add the 2, then you do 1 over that. Well, the 1 over x just gives you the shape. That's just the shape, okay? So we can ignore that. What's the next thing you would do? You take the opposite of it, right? You don't do the minus 1 next, you do the opposite of it. What does that do? That changes positive y's, the y from here, changes the positive y to a negative y. So it flips it this way across the x-axis, okay? So I'm going to do that next. So I'm doing these one step at a time, one transformation at a time. It's broken down into 4 transformations here. Okay? So notice the minus in front there. So this is upside down from this. Right? Okay, and then finally, what I would do here, if I were plugging 2 in here, I'd have 1 over 5. Then I'd have negative 1/5. Then I would subtract 1. So the subtract 1 moves it down 1, the graph. So the horizontal asymptote becomes minus 1. The vertical asymptote just slides along itself when you move down, so it stays where it was, right? And your vertices move down 1, right? So that's what the whole graph looks like. That was what was originally given. That's f of x. Okay? Now, don't just stop there, because you can easily make a mistake here, like go left when you're supposed to go right, etc. It's kind of like if you just learned to drive and they're telling you during your driver's test which way to go. You can easily go the wrong way. So you put in some test points. So I put in -2. Why did I pick -2? Well, that's where the vertex is here. Plus, it looks like a convenient number because it's near the center. Usually one to the right, one to the left of the center, and the center are good points to check. So I put in -2 for x. I get this. Don't forget the minus in front. And I get -2. And so -2, -2. That looks right. Now try -3. If I tried -3, I'd get 1 over 0. So I know the asymptote is there, so that's right. And now try -4. So I'm going to put in -4. And I get 0, which is where it is, right? -4. When x is -4, y is 0. So it's an x-intercept. Okay, so I know that's correct. There's no reason to be in doubt about most math problems. There's no reason to be in doubt about whether you got the problem right or not. The question should be, do you know how to do the problem at all? If you don't get an answer at all, of course, you're going to miss a lot of points, and you don't know it. But if you think you know it, you get to a reasonable answer, and you don't check the points, then you're throwing away. You're throwing away points on your test.